Are we just doing 6.4 today?
No, we're doing 7.1 as well. So we're going to start with 6.4. We got to finish off on determinants and Cramer's rule. This is going to be another fun one. 6.4, which is Cramer's rule. Okay, so Cramer's rule uses determinants. So just remind me again, I know we've done the quiz, but if I had a 2 by 2, 3, 4, 1, 2, the determinant, we call this A, the determinant of A equals what again?
There's 3 times 2.
3 times 2 minus
4 times
4 times 1.
4 times 1.
1
Oh,
times
that's a 4, not a negative 1. Okay.
That's a 4, yes. Okay? So this is going to be 6, 4 times negative, 4 minus 1 is, no, that's 4 times 1. 4 times 1 is 4, so 6 minus 4 equals 2. Okay? So we're good on the 2 by 2 matrices, right? 2 by 2 determinants. Now, the question is, it's not quite that easy with a 3 by 3.
Yeah.
Okay? So here's how, let me see here. Now, in the book, they call these minors, which is fine, I guess. I'm the cofactors. So let's say, for example, that I have 2, 3, negative 1, 0, 2, and 4, negative 2, 5, and 6. And I want to find the determinant. Okay? Wow. So when I do it this way, I can do it by any row or any column. So I'm going to do the top row, and then I'm going to do it again with the first column, and you're going to see why I like that. Okay? Now, trying to decide, they've got this big formula in here. Okay, so do you see that this is row 1, column 1? You agree with that?
Yeah.
So I'm going to add these row 1, column 1. That's going to be 2, which is an even number, which is a positive.
Whoa.
Okay? Now, if I were to take this one here, this is row 1, column 2, correct? Row 1, so 1 plus 2 equals 3, which is an odd number, so therefore it's negative. Okay? Row 1, column 3, 1 plus 3 is 4, it's an even number, so therefore it's positive. Okay? Now, that's the correct mathematical way to do this, and so the sign changes. Now, another way to think of it, if you don't like this, okay, you can also put, basically the signs alternate. So, and it always starts with a plus. Plus, minus, plus, minus, plus, minus, plus, minus, plus. If you want to do it that way, that's easier for you to remember, that's fine. It's the same thing I just told you, and it may be easier to remember, okay? So we're going to find the determinant, and you, like I said, you can either do it based on a row or a column. The book calls this a minor, okay? And so here's what we're going to do. We're going to change this 3 by 3 matrix into a series of 2 by 2 matrices that you all know how to do a 2 by 2 determinant, right? Question?
Wouldn't you just take the 2, 5 and the 4, 6 and make its own matrice? Like, or I'm just kind of going ahead, but.
Yeah, you're jumping ahead, so slow down. We'll catch up to you, okay? All right, so here's what we're going to do, okay? So the idea here is I'm going to take this minor, and so the idea here is I'm going to have 2 times something, I'm going to have a 3 times something, and I'm going to have a negative 1 times something, okay? Now I have to apply these signs here as well. So this becomes a plus 2, a minus 3, and a plus negative 1, so I'll leave that alone. Does that make sense so far? Okay. Now, so the idea here is when you're doing the minor, what you do is, so I've got this 2. So I'm gonna block out the row and the column in which the 2 is in, and I'm left with what?
3, 2, 5, 4, 6.
Now I'm just left with 2 and a 4 and a 5 and a 6. Do you see that? See what's uncovered? So I've got 2, 4, 5, and 6. Okay, yes?
Why do you leave the -1 alone?
Well, I can put plus -1 if you want. It's gonna go away anyway. Okay?
Okay.
All right, now I'm in row 1, column 2. Okay, so I'm gonna block out everything that the 3 is in, and what numbers are uncovered?
0, 2, 4, 6.
Oh,
4, 2, 6.
4, -2, and 6. Does that make sense?
Yes.
Okay, now I'm going to do this again, but we're doing it with the -1 now. I'm going to block out everything except for the -1. So what's left?
0, 2, -2, 5.
So 0, 2, -2, 5. Okay? Now, there is another way to do this. You're gonna have to check with the math lab, because this is always the way I do it. There is another way, and I'll kind of show it to you, but I don't know it very well. Okay, so at this point, we know how to do a 2x2 matrix. Hunter, what is the determinant of this?
So 2 times 6.
2 times 6 is 12 minus
Minus 5 times
20. And I'm gonna multiply that by 2, right?
Yeah.
Okay. Minus 3 times
0.
0 minus a -8. Minus 1 times
0.
0 minus -4.
Yes.
Okay? So then so 12 minus 20 is -8 times 2, -16. -3 times 8, -24. Negative times 4, -4. So -16 minus 24 is -40 minus 4 is -44. Okay, I know I was getting a little low on the board there, sorry. Okay,
That was supposed to be -4.
And a -8, I think.
okay. Super easy to screw up on signs. I'm pretty sure this is right, but we'll do it again. Okay, so you're asking about this one.
No. The 2 times -2 should have been -4 on the last one. Instead of +4.
Yeah, but you minus
So you
minus.
subtract it.
That's what I did on the.
Oh.
Okay, 0 minus -8, so that becomes plus.
Oh, I'm sorry.
0 minus -4 becomes plus. Yeah, super easy to mess up on these.
Simple math.
What's that? Okay, now, I want to show you that it doesn't matter which row or column you do this by, and you're gonna find out that if I were doing this, I would have picked the first column. Okay, so we're going to do the same determinant, and hopefully we get the exact same answer, but this time we're gonna use the first column rather than the first row.
2, 4, 5, 6.
Okay? All right, so in this case, let's pick on Victor. Okay, I want to expand by the first column. What are the coefficients for the 3 matrices that I'm going to start with by the first column? 2.
So it's
2 times something,
0, right? Minus.
0 times something,
Minus.
-2 times something. Okay, now we need to apply our things here. So this is going to be plus, minus, plus -2, okay? All right, so now I'm going to do this, right?
Yeah. 2, 4, 5, 6.
2, 4, 5, 6. And I'm going to do this.
3, -1, 5, 6.
3, -1, 5, and 6. And then I'm going to do this.
3, -1, 2, 4.
3, -1, 2, 4. Okay? Now, can you see that I really don't need to determine this because I'm going to multiply everything by 0, so it's going to fall out. I don't even really need to write that one down, correct?
Yeah.
So anytime you see a 0, that's going to save you some work. Okay? So now, Victor, can you give me the 2 times the determinant here?
12 minus 20.
Minus 0, minus 2 times
12 plus 2.
12 minus negative 2, which is 12 plus 2. 12 minus 20,
2.
negative 8 times 2. Negative 8 times 2,
Negative 16.
negative 16. 12 plus 2,
14.
14 times negative 2,
Negative 28.
negative 28, which equals negative 44. So I got the exact same answer I got here with less work. Okay? That makes sense? Yes.
Can you still get the inverse if you put that over?
Okay, so we're not talking about inverses on this. We're only doing determinants.
Kind of on a 3 by 3, can you times the action?
Yeah, inverses are not related to what we're talking about.
So what you're saying is the answer is 44 then, right?
Negative 44.
Negative 44.
Yep. Okay?
Is the determinant of that?
And it doesn't matter whether you go by the row or the column. And so usually what happens to me, although sometimes you're like, oh, I like the small numbers here better than those numbers there. Sometimes that's helpful, sometimes that's not. But usually, if I see a 0, I'm gonna use that because then it saves me some work.
And you could use any column and row.
You can use any column and row. Okay? I could do this middle row, or the middle column, or the middle row, or whatever. You cannot do a diagonal. Don't do a diagonal.
Legal.
Yeah, because you can't build your 2 by 2 after that. Okay? Now, there is another way, but I never remember how to do it.
That's fine.
Yeah.
No,
The math lab may show you, and you may like it better, but I never remember it, and so I don't teach it. But there is another way to do it with diagonals. But anyway. Okay, so
yeah, these are like doing this, they start breaking it down.
Like that is cool, that's cool, like that.
okay, well, this is interesting. I don't normally do a 4 by 4, but we'll do this one just for fun.
Yeah.
But this one's special. Okay? 1, 2, 0, 4, 0, 0, 0, 3, 5, 6, 2, 6, 2, 4, 0, 9. Okay? Now the idea works the same. What I'm going to do is I'm going to take any row or column, and then I'm going to turn it into a bunch of 3 by 3s, and then I'm going to turn those into 2 by 2s. But you'll notice one really cool row on here, won't you? Oh, yeah. Which one are we going to expand by? We're definitely going to expand by that row, correct?
Zeros.
Oh, we could do this one too. That's not a bad idea. Either way, we can do this one. That one's not bad either. Right? So either way. Okay? So we'll do the first one because that was the one that I noticed. Okay, so if we expand by this minor, okay, I'm going to get 0 times something, 0 times something, and the signs really don't matter because it's going to be a bunch of zeros, right? 0 times something, and then 3 times, this last one does matter, 3 times something, okay? Now, the question is, oh, thank you, camera, thank you. Okay, so the question is, I still do need to get the signs right because I don't know if this is going to be a positive 3 or a negative 3. So how do I decide? Okay, this is going to be plus minus, right? So that's going to be a minus, plus, minus, plus. Does that make sense? because the signs alternate. Another way, now the mathematical way to do it, where is this located? Row 2, column 4, right? 2 and 4 is 6. 6 is an even number, it's positive. Does that make sense?
Oh, okay.
Okay, so that's the other way to do it. That's actually the correct way to do it.
Say that again?
Okay, so 3 is in row 2, column 4.
Okay.
2 plus 4 is 6. 6 is an even number, it's positive.
So if it is in column 3, it'd be an odd number.
It'd be an odd number and it would be negative.
Okay.
And the other thing to remember is the signs always alternate. This always starts with positive, positive, negative, positive, negative. Positive, negative, positive, negative. Negative, positive, negative, positive.
Are you positive?
I am positive. Okay? All right, so now we need to block out everything except for everything in the 3 row and column. So if I block this out, this becomes
And it's 1, 2,
1, 2, 0,
5, 6, 2.
5, 6, 2, 2, 4, 0. Okay? All right, so now I need to turn that 3 by 3 into a bunch of 2 by 2s. What would be the best way?
I'll use that last.
Last column, right? We got lots of zeros there. Okay? So this is going to become 0 times something, 2 times something, and 0 times something, which I don't care because it's going to fall out, right? That's why I didn't care about losing space. Okay? Now the question is this going to be positive or negative?
Negative.
Row 3,
Positive.
row 1, column 3 is going to be positive.
Yeah. Positive,
Yeah.
negative, positive.
I mean, you don't
Positive,
prefer it.
negative, positive. Negative, positive, negative.
Oh, I'm sorry about this, the 2 rows, like, no, that's good.
Okay? Does that make sense?
Yeah.
So all I really care about is the 2, right? This is the only matrix I care about. So I'm going to block this out. I'm going to be left with
1, 2, 2, 4.
1, 2, 2, 4. Okay? All right, so this becomes negative 2 times
Negative 2 times 4 minus
4
1,
minus 4,
4.
which is, gives me a big fat 0.
So what is that?
What does that mean?
Dependent?
Okay, actually, now that I think about it, Berkeley was onto something here. What does that mean, Berkeley? Oh, you were talking about inverse matrices, and I said it didn't matter. It does.
That means they're not inverse of each other.
This is not invertible,
I was right from the beginning.
okay? If your determinant is 0, you can't find an inverse matrix.
I thought we were looking.
Does that apply to-
No, it's true.
On that one, so if we
But there's
had
no
gone
determinant.
different, if we had gone a different
Determinant
number.
is 0, remember if you have a 2 by 2,
I'll just wait, it's okay.
sorry.
You're okay.
Finish this thought. Remember, we did 1 over the determinant, and if your determinant is 0, it doesn't matter what the rest of the matrix is. It's illegal, right? So therefore, if you get a determinant of 0, the matrix is not invertible.
Okay.
Okay? All right, go ahead, Kelly.
So if we had gotten a different number than 0, we would times that by negative 2, right?
What are you talking about?
So like if it was a 1 instead of a 0.
If this was a 1?
Yeah.
Okay,
So.
What would you do?
then
Right,
it is
if we got
invertible.
1 inside, so 4 minus 3 or whatever would be 1. Would you times that by negative 2?
Yes.
Okay.
1 minus 3 is 1 times negative 2, so that would be
So-
negative 2.
And then that negative 3 on the outside of that positive 3, do you ignore that? Once you,
Oh, I didn't think about that.
do you have to
But 0
times it by
times
3
3
again?
is-
Oh, you're right. No, you don't ignore that, because now we have to take that 3 and multiply it by 3, and that's negative 6.
Okay.
Wait.
I was so focused on the 0, I forgot about the 3, but you're right, yeah, don't forget about that 3.
Okay.
So it's not a 0, so it's that times.
Well, it's still 0.
Well, it is,
It's 0 times 3.
because this is a 4, and this is 0. And so then if you multiply that by 3, you're still gonna get 0. So you were correct. So yeah, Kelly was good to say, hey, don't forget about that 3, which I forgot about because I knew it was gonna be 0 anyway. It didn't matter.
I think it was gonna be 0.
But if you were doing this, don't forget about the 3.
Okay.
Yes.
So this is completely separate from finding the inverse. Is this just to confirm that we will have an inverse? Or is does this help us at all with finding?
So if your determinant is 0, you will never be able to get an inverse.
Right. But if that number, say, was 2,
Like,
Would
Then
that
you can
help
get an
at all?
inverse.
would that help with the inverse at all?
like. I
It would
think
help
it's
with
like
the
what
2
we
by
should
2
do
to get
with-
the inverse. After that, any of this other stuff, you gotta go through all this stuff and it's,
So you still gotta go through and
yeah.
do the opposite.
Yeah.
Okay.
So yesterday you said that if there's a row that's all zeros except for one number, then there's no inverse. Is that also,
Yeah, well,
is that
see-
also true with the column?
Is that also true with the columns? Yeah, it would be true. Yeah, if we had expanded by that column, it wouldn't have mattered.
Okay.
Yeah.
So as long as.
So could we just look at that and be like, there's no inverse?
If you want to memorize every single case, yeah, sure,
Oh,
but I don't
okay.
memorize that.
Okay.
I just do the math and say, oh yeah, it's 0. Okay? All right, so, gosh, after all that, we still need to do Kramer's rule. No, that was getting ready for Kramer's rule. Okay, so here's what Kramer's rule is. All right, so Kramer's rule says, let's say that we have a 2 by 2, ax plus by equals c, no, it's equals r, sorry, and cx plus dy equals s. And I hate the letter s because it looks too much like a 5. Okay? So if you have this, then you can say that x equals, we refer to this as the solution set. Okay? So what I'm going to do is I'm going to replace the solution set with the x variables. So this becomes rs, and then I'll leave this the same, vd, divided by this, a, b, c, d. Okay? And then y, also, you're going to take your solution set and you're going to put it in the y column. So this becomes a, c, rs over a, b, c, d. Okay? So, and of course it works for, it'll work for a 3 by 3 as well. So I'm just showing you the case for a 2 by 2. We'll do a 2 by 2. I'm worried about running out of time. And then we'll do a 3 by 3, and I'll show you that. I'm going to try to move a little quickly because I want to make sure we cover 7.1 as well. Okay, so let's say that I have um, 2x plus 6y equals -1, x plus y equals 2. Okay? So this is, so what we can say is, according to Kramer's rule, I'm going to take these and I'm going to substitute it for the x. Okay? -1, 2, 6, 1. And 2, 6, 1, 1. Does that make sense?
Is it and or over?
Divided by.
Can you explain like how you got those two like matrices?
So these are just the coefficients of this side, 2, 6, 1, 1. This one is, I'm going to substitute this for the x column. So -1, 2, and then 6 and 1.
Oh.
Okay? Now, these are easy to find the determinant, right? So the determinant on the top is -1 minus 12 over 2 minus 6, which equals -13 over -4, or 13 fourths equals x. Okay? I can do the same thing for the y. Now, in this case, I'm going to substitute this for the y column. So, Hunter, can you tell me what these matrices are? No? Okay, Okay, so we're gonna take these two coefficients are
So 2 and 1.
2 and 1, and then we're gonna substitute this -1 and 2, right? And then we're gonna do the coefficients of just this side,
Okay, so 2 and 6.
Oh.
And then
2 and 6.
1 and 1.
Okay, so we already know the bottom's gonna be -4, right? The top's going to be 2 times 2 is 4 minus -1. So this becomes -5/4 equals y. Okay? That's Kramer's rule. So that was a lot less steps than doing it with the substitution and elimination, right?
I like that.
Yeah, that's not too bad, right? Should we do it with a 3x3?
Sure.
Sounds fun.
Okay, so one way to write this, another way is, you can say that x, oh, I was off camera again. Hopefully, you guys didn't tell me that, but there you go. You can kind of see that now that I've done the problem. Okay, so let's do the equations. 2x minus 3y plus 4z equals 1. X plus 6z equals 0. 3x minus 2y equals 5. And I want you to solve this with Kramer's rule. So Caitlin, okay, so let me just show you some shorthand. One way to say this is x equals d of x over d, y equals d of y over d, and z would equal d of y over d, where d represents the determinants. Okay?
So you're gonna set that up in the matrixing
Okay.
matrix first, right? So it's
So let's find matrix D, which will be my denominator,
the denominator.
okay? Which is gonna be
So it's
just the
two-
coefficient of this side.
Okay, 2.
2,
Oh, backside, what do you mean, right? So it'd be 2, 1, and 3? Is that what you're
oh, you're
saying?
going in columns, 2, 1, and 3, okay? And
And
then
then -3, 0, 2.
-2.
Yeah, no, you're so sorry. And then 4, 6, 0.
Okay, so what would be the easiest thing to expand on?
The 106 probably.
Yeah, probably the 1, 6.
Probably the 1,
You
0,
can't do
6.
diagonals, right?
Can't do diagonals. That's sad, huh? That would have been a nice diagonal, but you can't do diagonals, okay? So we're gonna have 1 times something, 0 times who cares, and 6 times something, right? Because that's gonna fall out.
Okay.
Okay, so now the question is this positive or negative?
That one is negative.
Negative, and this one is
Negative.
also negative, okay? So in this case, cross out the ones, we're left with
Okay, we're left with 3, 4, -2, and 0.
-3, 4, -2, and 0. Cross out the 6, and we're left with
You're left with 2, -3, and then 3, -2.
2, -3, 3, -2. Okay, so this becomes negative 3 times 0,
0.
0,
And then -8.
minus -8.
Yeah, so
This is
minus
a
negative
really
8, so it's a positive 8.
Positive. This is a really good place to mess up on signs.
Okay.
So be super careful on this.
And then
Minus 6 times
-9, right?
2 times -2,
Oh, sorry, 2 times -2 is -4.
-4 minus
Minus a -9.
-9. Okay, so this gives me -8, -4 plus 9,
Is 5.
5 times -6,
-3.
-30 equals -38. Okay, so the idea here is my denominator and everything is going to be -38. Okay, we're running out of room, so we're going to have to go over here. Now, Angel, can you tell me what dx equals? Now that I've erased your thing here. d of x should equal what? Here, I'm gonna try to get both of these on here, so I think we can see both of those. Okay, so I'm gonna substitute this in for which column?
For the
The first column. Okay, so this is gonna be,
1,305.
okay, and then the y column's gonna stay the same.
So -302, 460.
460, okay, how are we gonna expand that one?
It's -2 on the bottom.
Yeah, it's -2 on the bottom, thank you. Okay? And then, we're gonna expand again by this middle row, right? Because we like zeros.
Yes.
0, 0, and we're gonna be left with a 6 times a 2 by 2, right? And the question is that positive or negative?
That's negative.
-6, okay? So we're left with 1, -3, 5, -2. So -6 times
1 times
-2 minus -15. So that's going to be 13 times -6, which is 13 times -6, so 6 is 18, 78, minus 78. So x is going to equal -78 divided by -38, which is whatever it is. I was hoping that would be a better number. Is that not nice? Did they give us a bunch of mean numbers on here? Oh, no, they did. Yeah, 39/19.
2K.
That sucks. Okay, then it's correct answer. Would you like to do that with elimination or any other way? So it's suck, right? Okay?
Question for clarity. So we're replacing the 105 with the first column
Mhm.
to find x? Okay.
So you have to find.
So now how do we find dy?
So we replace it with the y column.
With the y column. So so here, because on time, I just want to set this up and then we'll give you the answer. But the matrix should be
2, 1,
2, 1, 3.
3. Oh, I'm sorry, I was going by row. And then 105,
1, 0, 5,
460.
4, 6, 0. Okay? When you find your d sub y, you should get, I'm just going to give it to you because we're running out of time. It's going to be -22 divided by -38, which we got there, which equals 11/19. Okay? D sub z, just to set this up, is what, Christian?
For z,
Uh-huh.
you should go back to the original equation,
Mhm.
so just 4 and 6.
So what?
You just go back to the original, I don't know, I'm really lost.
Yeah, but it's been lost over.
Okay, so we're going to keep the coefficients here.
Okay.
Coefficients here are
The 2, 1, 3.
2, 1, and 3. We're keeping the y's.
Okay, so -3, -2.
-3, 0, -2. Don't forget the 0.
The
The last column is going to be,
460.
no, because we're substituting this for your z column,
Oh, so then 105.
105. Okay? We can find that determinant, and when we do, determinant of z equals, according to this, 13.
Yeah,
Yeah, 13, and so z equals determinant of z over d, which equals 13 over -38. Okay? So hang out in the math lab, make sure you got this down, because it's going to test
Oh, I
tomorrow.
know, it doesn't matter every day.
Okay? Good.
Okay, so start from the beginning. When we found D,
What is that?
yeah. That's the determinant, so is that the denominator for X, Y, and Z?
Okay, I'm having a bit of a dilemma here. Because there's no the reason why I'm rushing through this is because somebody has to take the test today. And so I had to write the test before, thinking I was gonna get through both sections.
Right.
And I feel bad about rushing through this, because we don't need to rush through it, but we
Right.
needed to for the test that I've already written,
How about you just take out those?
So here's
questions
what I'm
on the
gonna
test
do.
for a short test?
okay? Because I don't wanna rush through this, I wanna make sure you guys understand this. And there's no reason to, the only reason to rush is for the makeup exam that I've already written for 3 people. Okay? And that's why I was trying to rush through. But I don't want to rush through this because I know this is confusing. So there's going to be one question on there from 7.1, which I'm going to make an extra credit question. Okay?
Can you clearly mark that it's from 7.1?
Well, you'll know because it's about a parabola.
Oh.
And it has nothing to do with
I'm just
it.
gonna put
So
three.
much.
Okay? So anyway, this is why I don't like to write my test before class, but I had to in this case. So I don't want to rush through this. So I've already written the test. I'm not going to change the test. Everybody has to take the same test. And so we're not going to do, so there will be a 7.1, but it's going to be extra credit. Okay? Does that make sense? So we're still taking it tomorrow. And we're not going to cover the parabola till
And
Monday.
we'll still have like the review.
So it'll be a good practice.
Will it still be on the review,
Okay.
you're right? The 7.1.
I haven't made the review.
Another review.
So I probably won't put the parabola on the review because it'll be on the next review. Okay? So anyway, so don't worry about that. But I want to make sure, Christian, okay, we're slowing down because I know that we're going too fast.
Okay.
And we don't need to. We need to, but we don't need to. Okay? So anyway, that's what I'm gonna do. Okay?
Okay.
So let's make sure we've got this down. And I know I flew through this, but I want to make sure, especially Christian, thank you for saying, I don't know what I'm doing, because it made me slow down. Okay?
You're welcome.
Okay. What is D and why is it important?
D stands for determinist.
You have to erase this part, because I think this part what makes it.
Yeah, the problem is I only have a certain amount of words.
Okay, that is.
Well, can you write the like dy thing equals whatever, that thing again that you had wrote?
Say it again. Okay, so do you want me to review Kramer's rule again? So
Is this Kramer's rule over D?
this is all Kramer's
Yes.
rule.
Okay.
Kramer's rule deals with determinants.
So you had wrote some shorthand, so I just want like the
Yeah.
shorthand again.
So in a nutshell, I need to erase something. This whole board is one problem.
We read it on that one.
Yeah, but you won't be able to see it.
Okay.
Never mind, just erase it, just erase it.
Okay, we'll do this again. We'll finish on this, okay?
Yeah, let's do one more really slowly.
Yeah, one, yeah.
See, this one was kind of a mean one because it's got all these nasty fractions in here, but it's okay. You want me to just make up one?
Yeah, let's just make up.
Okay. So Kramer's rule, so let's review this one more time. Kramer's rule. Okay, now there's the shorthand method, okay? X equals D sub X over D, Y equals D sub Y over D, Z equals D sub Z over D, which sounds really simple, but it's very complicated, okay? Now, let's assume we're doing a 3 by 3, okay? I'm gonna have a matrix, I'm just gonna make this up. 1x plus 2y plus 3z equals 4. These could be ugly. Negative 5x minus 6y plus 7z equals 8. These are going to be ugly, but it won't matter because it's Kramer's rule. 3x plus 2y minus z equals 4. I don't know. Okay? Now, the question is, can we properly define, okay, d sub x, d sub y, d sub z, and d, okay? Remember, the d is always going to be the same on all three of these, okay? All right, so What is D? Dino? D for Dino. Do you know what the matrix is that defines D? No, that was the wrong answer. That's the right answer, but it was the wrong answer. Cameron, do you know?
Yeah, is it 1, 2, 3 for the top row?
Okay, 1, 2, 3. It's just the coefficients of these.
Yep, -5.
-5,
-6,
-6,
7.
7,
3,
3,
2,
2, -1. Okay? All right.
And we have to choose a.
Does that make sense? Dina? Yes. Does it make sense, Christian?
Yeah, so you
Is there anybody else who's lost? Okay? All right. Now, the idea here for d sub x, okay, is going to be the same thing, but since it's the x variable, I'm going to replace this column with the x. When we're in the y, I'm going to take this column and replace it with the y. When I'm in the z, I'm going to take this column and replace it with the z. Does that make sense, Christian?
Yes.
Dino?
Yeah, but aren't they all just gonna be the same number then?
No, they won't. Because I'm replacing this. If it's the x, I'm going to put it there. If it's the y, I'm going to put it there. If it's the z, I'm going to put it there. So they'll all three be different matrices. Most of it will be, 2/3 of it will be the same. 1/3 of it will be different. Okay? All right, so let's go back to Christian. Can you tell me what this matrix is supposed to be?
Yeah, so 4, so going down 4, 8, 4, 2, -6, 2, 3, 7, -1.
Dino, can you do the same thing for y?
Yeah, it'll be 1, -5, can't see bottom, 3, and then 4, 8, 4 for the middle, and 3, 7, -1.
Okay? And Cameron, indoor stadium.
Let's see, so it'd be 1, -5, 3, 2, -6, 2, and that'd be 4, 8, 4.
4, 8, 4. Okay? Now, once you've got that, theoretically, this isn't that bad. Okay? Now, all we've got to do is figure out we've got 4 determinants to figure out. But we're going to turn those 4 into 12. Okay? So, Bailey, which one do you want to do?
Let's start with the
Start with what?
DX.
dx?
Yeah.
Okay, so let's figure out dx. Okay, we've got to turn a 3x3 into 3 2x2s. So which row or column looks best? And it's probably none of the above. We might need a calculator for this one,
Yeah.
because I made it up. And it might be really ugly, but that's okay.
Okay.
As long as you understand how to set it up and get your signs right, because this is the best place to screw up signs. Okay? So which one do you want to expand by? The bottom row? Okay, bottom row, that looks pretty good. Okay? So my coefficients are going to be 4 times something,
And 2.
2 times something,
And then
-1 times something. Now we have to apply the plus minus plus to these. What is the sign of this? Positive. How do you know?
Because it's in the first column and then third row, so that's.
Yeah. So row 3, column 1, 3 and 1 is 4. It's even number, it's positive. This one's going to be negative
Oh, negative,
and
sorry.
positive. Okay? All right. So now, what are we going to do?
So we need to cover the 4 and the 2, 3, -6, 7.
So 2, 3, -6, 7. Okay?
And then for the 2, we'll do 4387
4387.
for the -1. We'll do 42896.
428 -6. Okay? All right, so then this becomes what? 4 times
4 times 2 times, wait,
2 times 7,
that's 14.
14 minus
-18.
-18. Okay? Minus 2 times 28 minus,
minus.
you always subtract, remember?
So why do we subtract?
That's the definition of the determinant.
Okay. So minus 24.
24. Minus 1 times
-24.
-24 minus
16.
16. This one wasn't as bad as I thought. 14 plus 18 is 32 times 4 is a big number. What is it? 128. 28 minus 24 is 4 times 2 is -8. -24 minus 16, -40 becomes +40. So 40 minus 8 is 32 plus 128. 32 plus 128 is 160, I believe. Is that correct? Okay, so that's the numerator. Now, in order to find the x, we need to find the denominator. Okay? Kelly, can you do the denominator?
Yeah.
Okay? So here's my denominator.
Oh, I can't see it.
Oh, sorry, I should pick on, here, pick on 100 since you're in the front.
No, I don't know.
Okay, well then you better know. We're gonna help you. We're gonna make you do well on the test tomorrow, whether you like it or not. Okay, so this is my determinant. You wanna expand on which row or column which likes the best numbers? Top row definitely links best, right? Okay, so my coefficients are gonna be 1 times something, 2 times something, and 3 times something. Okay, now we've got to get our signs right. Positive, negative, positive, right? Okay, so now we're going to block out this and we're left with -6, 7, 2, -1. And then we're going to block out this. -5, 7, what?
3 -1.
3, -1. And then
-5, -6.
-5, -6.
3 and 2.
3 and 2. Okay? All right, then what?
Determinant.
1 times
6 minus 14.
minus 2 times
5 minus 12.
plus 3 times
Equals 10 minus 18.
minus a -18.
Wait, is it 5?
What'd you say?
How's it 5?
How's what 5?
Or in the middle one, how is it 5 minus?
-5 times -1 is +5.
Oh, it's times.
Okay? All right, so then this becomes 6 minus 14 is -8. 5 minus 21 is -16 times -2 is +32. -10 plus 18 is 8 times 3 is 24. So 32 minus 8 is 24 plus 24 equals 48. Okay, so what does x equal in this case? 160 divided by 48, which is 80 over 24, which is 40 over 12, which is
20 over 6.
divided by 4, 10 over 3, 10/3. Okay?
So then we find y equals z.
Would you kindly slow down, Christian?
Huh?
Are you glad we slowed down?
Yes, very much.
Hunter, do you understand more than you did 5 minutes ago?
Yes.
Okay, well, I've made success there. Christian,
So when you went back to find the numerator, you just went back to the first matrix box that we made, and did you pick any row that you wanted, or did it have to be the top row?
Just pick any row.
you can pick any row that you want.
Okay.
On this, the bottom row looked best. On this, the top row looked best.
Yes.
Okay?
Does
Yes.
that mean where we go find D of Y?
We need to find D of Y, D of Z. We're gonna run out of time to do that. Okay, so I'll let you, I completely made this up. That's why they're nasty numbers. I'm sorry. Yes.
So when we got 48, is that we're gonna use for the bottom, for all, just D on all three?
Yeah, the 48 is gonna be what we're gonna use for D on all these. So all of these are gonna be divided by 48. 48. So I don't need to figure that out again. Okay? Question?
I was just gonna ask if we multiply the top of the numerator by D as well, or is it just?
No, D stands for determinant.
Okay.
So you just find the determinant. The determinant of X divided by the determinant of all your coefficients.
Okay.
Okay? All right, any other questions? Okay, are you glad we slowed down?
Yes.
Are you excited for me to credit power tomorrow?
Oh, definitely, yes.
I'm gonna attempt
Good luck. All right, so see y'all tomorrow.
So is there like any input besides the parabola, like any part?
Well, if you, here's my deal.